Hi all. This video is mainly aimed at clarifying you about quadrature null effect. Quadrature null effect occurs during the demodulation of double sideband suppressor carrier AM signal. The device used for demodulation of DSBSC AM is called as coherent detector, also called as synchronous detector. In coherent detection, as the name implies, the incoming modulated signal is going to be multiplied with a local carrier signal. This carrier signal must be same in frequency, same in phase as the carrier used at the transmission side. It means if I am using a carrier signal cos omega ct, same carrier signal cos omega ct must be produced by the local oscillator. Then we call they are exactly in coherence. However, because of the channel problems, there exists a phase mismatch or frequency mismatch between these two carriers. Okay, I know that cos omega ct is used at the transmission side. By using the local oscillator, I have produced cos omega ct, okay. But because of the propagation considerations, I may not receive cos omega ct exactly. There may be a phase error, phi, for example, introduced during transmission. In such a case, when there exists a phase mismatch between the local carrier signal and whatever you are receiving, then we encounter something called as a quadrature null effect. This quadrature null effect can be defined as the disappearance or vanishing of the disappearance or vanishing of the message signal at the output of the coherent detector. How it occurs as like follows. Let me take a case. The as in coherent detection, we are going to multiply the incoming signal, that is incoming modulated signal. Let me take S of t. S of t can be called as a DSBSC signal, which is given as S of t equals to M of t, that is message signal, into C of t. This is standard expression for your double sideband suppressor carry AM signal known to us. Now, what is happening if I expand this? This is equal to M of t into AC cos omega ct. Say, we have received the DSBSC signal without phase error. Okay, without phase error. But the local oscillator present in the product coherent detector is going to have a phase error of phi. Say, instead of producing AC cos omega ct, it is producing AC dash cos omega ct plus phi. What is the meaning of the phi? This phi is the phase difference between a transmitted carrier and the locally generated carrier signal. These two signals are given to, okay, these two signals are given to the product modulator. What is a product modulator? A product modulator takes two inputs. That is, one is DSB-SC signal, second one is the locally generated, which is given to product modulator. The output of the product modulator is given as x of t, say, which is nothing but s of t into AC dash cos omega ct plus phi, right? Which means if I substitute the DSB-SC signal, this will be equals to AC cos omega ct into m of t into AC dash cos omega ct plus phi. What is this AC cos omega ct plus phi? This is nothing but the phase difference between the locally generated signal and DSB signal received. Now, if these two are multiplied, But two, one is DSBSC signal, second one is the locally generated signal. If they are multiplied, then the corresponding output will be given as x of t equal to, as I have just told, x of t equals to AC cos omega ct into, let me just mention here, x of t output equals to AC dash m of t into cos omega ct cos omega ct plus 5, right? So what next? If I just multiply and simplify this, this will be equals to AC dash by 2. That is, I am dividing by 2 and multiplying 2. I have AC dash by 2 m of t cos 2 cos omega ct cos omega ct plus 5, right? Okay. In such a case, we all know the 2 cos A cos B can be given as 2 cos A cos B equals to cos A plus B cos A minus B. If that is substituted here, 2 cos A cos B corresponds to, okay, cos A plus B means what? Cos A plus B will be corresponding to cos omega ct plus cos omega ct plus omega ct plus 5, right? So in such a case, the output will be AC dash by 2 into m of t into cos A plus B. That is cos 2 omega ct plus 5, right? Plus cos 5, right? This is the output of the product modulator. This output of the product modulator is passed through a low pass filter. What is the low pass filter? A low pass filter passes low frequency components and attenuates high frequency components. So the term corresponding to cos 2 omega ct plus 5 is removed by the low pass filter, thereby giving y of t. What is the meaning of y of t? Y of t is the output of the low pass filter, which gives AC dash by 2 into m of t cos phi. Now, if the value of phi is 0, message signal is reproduced effectively. That is, y of t equals to AC dash by 2 into m of t. Okay. If phi value is 90, what happens? Cos 90 is 0. It means message signal disappears. There will not be any output at the output of the coherent detector. This phenomenon is called as a quadrature null effect, which occurs in the demodulation of double sideband suppressor carrier AM signal. And why this is occurring? This is occurring because of phase mismatch between the transmitted carrier signal and locally generated carrier signal. If I just mention one example case, take a classroom. In the classroom, one faculty is taking a class. If the faculty and the students are in synchronization, then whatever content delivered by the faculty will be caught by the student. The student can understand. But the faculty is teaching something and the student is thinking something. Definitely, there will not be any specific outcome. If there is synchronization, the student understands. If there is no synchronization, the student cannot understand. Same is the case in coherent detection also. If there exists exact phase mismatch, message is reproduced. If there is no phase match exactly, message is not produced. This phenomena is called as quadrature null effect. This quadrature null effect can be avoided by number of approaches. We have three techniques primarily: pilot carrier method, Costas loop, and squaring loop. These three techniques can be called as carrier recovery circuits. Why carrier recovery circuits? Why the problem? The problem of quadrature null effect is occurring because of carrier signal having some difference, some deviation. So, by using any one of these techniques, we can be able to retrieve the carrier signal at the receiver side. That is why these techniques of pilot carrier method, Costa's loop, and squaring loop are called as carrier recovery circuits, which are meant for eliminating the problem of quadrature null effect. Thank you all.